Hello students, welcome to TALANTA chemistry class. Myself Dr. Abhishek Dhar. Today we are going to discuss some PYQs from the chapter Haloalkanes and Haloarenes of class 12 and the questions are all previous year questions which had come in the CBSE exam. So by watching this video, I'm sure that you are going to get a proper idea regarding the question pattern of CBSE boards in this chapter. So let's begin with question 1. It's a multiple choice question. Consider the following reaction. These alkene CH3CH double bond CH2, it is being treated with HBr and then aqueous KOH is given. So the first thing is that question 1 we are going to solve. CH3CH double bond CH2, when it reacts with HBr, simple Markovnikov addition will happen, this one, and then aqueous KOH will lead to substitution reaction. Ethanolic KOH will lead to elimination, but here aqueous KOH is given, so substitution reactions Br will be substituted by correspondingly OH. So this will be the product. So option A is the correct answer. Next we'll move to question 2. Which one of the following halides contain sp2 and halogen bond? Allyl halide. Okay. So and vinyl halide. So what we have to do, we have to draw the structure. Allyl halide, this one. This is allyl halide. Next, alkyl halide. Sort of CH3X. We can write it in this way, RX. Next, benzyl halide. This one. And next, vinyl halide. This group is referred as vinyl group, so one halogen is attached with it. So in the question they have asked that the carbon which contain the halogen will be sp2 hybridized. Let's check. So this carbon, this is sp3, steric number is 4. This is again sp3, benzylic, this carbon is sp3. But here, this carbon, you see the steric number is 3. So the hybridization state will be sp2. In all the other cases, the steric number are becoming 4. The hybridization of carbon atom corresponding is becoming sp3. But here, as the steric number is 3, so the hybridization will be sp2. So vinyl halide will be the correct answer. Option D. Next, we'll move to question 3. Consider the following compounds. Cyclohexyl chloride, cyclohexyl methyl chloride, and benzyl and chlorobenzene. The correct order of reactivity towards SN2 reaction. In SN2, backside attack will be favorable and 1 degree will be most dominating, then 2 degree, then 3 degree. So this is 1 degree, this one 1 degree, this one is 2 degree, but this is haloarene due to this double bond character of CCl bond due to resonance. It is very inert towards substitution reaction. Any halobenzene, it needs very drastic condition to make the reaction happen. So these 3 will be the least reactive towards SN2. Being 1 degree alkyl chloride, 1 will be the highest and 2 will be the intermediate. So 2 will be the highest. Sorry, this 2, this is 1 degree, 2 is the highest, then 1 and then 3. Option C is the correct answer. Next, question 4. Major product formed in the following reaction is. Well, what we have to keep in our mind, when a 3-degree alkyl halide is given in presence of a base like NaOCH3, here elimination reaction happens. E2 mechanism, this O minus abstracts this proton, this sigma bond shifts over here, and Br being a good leaving group is left. So this product will be formed. Means alkene will be formed. So option D is the correct answer. Next, question 5. Enantiomers differ only. Boiling point, no, enantiomers have same boiling point. Rotation of polarized light, yes. For enantiomers, rotation of plane polarized light is just reverse of one enantiomer to another. So rotation of polarized light will be different for enantiomers of same compound. This is a very important information. So option B is the correct answer. Next, we'll move to question 6. Which of the followings is optically inactive? Plus butan 2-ol. We have to draw the structure of butan 2-ol. This butan means 4 carbon atom will be there, and this is the structure of butan 2-ol. And this carbon is chiral, as 4 different groups are attached with these carbon atoms. So being having a chiral carbon, it is normally optically active. So plus 2 butanol, this is one enantiomer, this is optically active. Minus 2 butanol will also be optically active. Plus minus butan 2-ol. What does it mean? Plus minus butan 2-ol means is a racemic mixture. 50% of plus butan 2-ol and 50% of minus butan 2-ol. Any racemic mixture becomes optically inactive due to external compensation. So plus minus butan 2-ol is representing nothing but racemic mixture, and this racemic mixture is optically inactive due to external compensation. So here option C, that is plus minus butan 2-ol, is the correct answer. Next, we'll move to question 7. Which of the followings has the highest boiling point? Option A, C2H5F, next C2H5Cl, C2H5Br, C2H5I. Here, boiling point for these alkyl halide, boiling points are directly proportional to the van der Waals attracting force, which is directly proportional to the molecular weight of the corresponding alkyl halide. So C2H5I has the highest molecular weight among these 4. So C2H5 has the highest intermolecular van der Waals attracting force operating between the molecules, and that's why ethyl iodide will have the highest boiling point. Option D is the correct answer. We'll move to question 8. Which of the following isomer of pentane C5H12 will give 3 isomeric monochlorides on photochemical chlorination? Photochemical chlorination means it will happen in presence of photon, and it happens through free radical mechanism. So 3 types of hydrogen should be present to give 3 different monochloro derivative. The first one, this will give only one monochloride. Only one monochloride will be given by this one. So N-pentane, when we are considering N-pentane, one monochloride is this one. One chloropentane, another one is this one. This is 2 chloropentane, another one is this one. this is 3-chloropentane. These 3 monochloro derivatives are possible for N-pentane. So in the question it has been asked which will give 3 monochlorides. So N-pentane, that is option 2 is the correct answer, option B. Next, assertion reason type question. Assertion, they are telling chlorobenzene is less reactive towards nucleophilic substitution reaction. Reason, nitro group in chlorobenzene increases the reactivity towards chlorobenzene is less reactive towards nucleophilic substitution reaction. This is true. Nitro group in chlorobenzene increases its reactivity towards nucleophilic substitution reaction. Yes, this is also true, because in presence of the minus I and minus R effect of nitro, the CCl bond of chlorobenzene becomes weaker, so it leaves more faster and the reaction becomes more facile in presence of a strong electron withdrawing group like nitro. So both A and B are true. That's fine. It's both A and B are true. But it's these two are different statements. This is not at all the reason why chlorobenzene is less reactive towards nucleophilic substitution reaction. So both A and R are true, but R is not the correct explanation of A. Yeah, that's it. So option B is the correct answer. Next, one type of question has been introduced in last 2 years in CBSE paper in each subject. This is case study sort of question or passage based questions. So they normally provide a long passage and there are some informations, but I think as per the passage is concerned, the information which they provide, if you read the chapter in a proper way, you can get all the informations which are written in the passage. So you basically don't need to read the passage if you know the related information in a proper logical way. But still, when a passage is given, try to read the passage with full concentration. It may happen that you are going to get an extra point, extra information which you don't know, and that extra point or extra information which is given in the passage maybe perhaps going to help you to answer the questions. Well, so what the passage says, the substitution reaction of alkyl halide mainly occurs by SN1 or SN2 mechanism. Whatever mechanism alkyl halides follow for the substitution reaction to occur, the polarity of the carbon halogen bond is responsible for these substitution reactions. The rate of SN1 reactions are governed by the stability of carbocation, whereas for SN2 reactions, steric factor is the deciding factor. If the starting material is a chiral compound, we may end up with an inverted product or racemic mixture depending upon the type of mechanism followed by alkyl halide. Next, cleavage of ethers with HI is also governed by steric factors and stability of carbocations, which indicates that in organic chemistry, these two major factors help us in deciding the kind of product formed. On this passage, we are going to solve the 5 questions which are given. Question 1, predict the stereochemistry of the product formed if an optically active alkyl halide undergoes substitution reaction by SN1 mechanism. So, question 1, the answer here, the question 1 for the passage, question 1, if SN1 happens, then stereochemistry inversion of configuration takes place of the product. Inversion of configuration of the product takes place. That will be the answer. Next, question 2, asking name the instrument used for measuring the angle by which the plane polarized light is rotated. Well, this is a very common instrument. This is referred as polarimeter. polarimeter. Next, question 3. Name the no, sorry. Question 3. 2-bromopentane plus alcoholic KOH is forming major product A. What will be the major product? 2-bromopentane this one, 2-bromopentane, when it reacts with alcoholic KOH, elimination reaction will happen and it will follow Sadjev rule to give the alkene which has more number of hyperconjugative hydrogen atom. So CH3, CH, double bond CH, CH2, CH3. This is the major product we are going to get, and minor product in this reaction will be this one. So minor product. Well, next question 4. Give one use of iodoform. Iodoform is used, it's a disinfectant. It is used as disinfectant. CHI3 is used as disinfectant. Next, question 5. What are formed when anisole reacts with HI? Anisole means methoxybenzene. So it will give phenol plus methyl iodide. Next question, they are asking, write the major products in the following. It was CBSE 2016 question from Haloalkanes and Haloarenes chapter. This compound is given paranitroethyl benzene that is being treated with Br2 in presence of UV light. When halogenation reaction of any hydrocarbon or aromatic, that may be, or aliphatic, hydrocarbon happens, halogenation of hydrocarbon when happens in presence of sunlight, UV light, photon, then you always remember the reaction proceeds through most stable free radical formation. So here we have to find out where the most stable free radical will be formed. Here CH dot 1H will be liberated from here to form CH dot. This radical is highly stable because it is 2-degree benzylic radical, and Br dot will be inserted here. So the product will be this one. CH-Br CH3. In presence of UV light, bromination is happening in highly stable benzylic carbon. Next, question 2. This isopropyl chloride, 2 moles are given, is reacting with sodium and dry ether. This is nothing but Ward's reaction. From Rx, we are going to get RR. So what will be the product? Here the R is CH3, CH, CH3. This will be clubbed twice. So this is the product here. Next, question 3. CH3CH2Br is being treated with AgCN. So obviously here phenyl isocyanide or isonitrile will be formed, means NC will be produced. It's done. Next, question 15. Give reasons. CCl bond length in chlorobenzene is shorter than CCl bond length in CH3Cl. 15A. This is chlorobenzene. The CCl bond in chlorobenzene is getting partial double bond character due to the above resonance, and that's why due to this partial double bond character the CCl bond length becomes shorter. But in case of CH3Cl, so no resonance is possible. So CCl bond has 100% single bond character in methyl chloride, and that's why CH3Cl in CH3Cl the CCl bond is longer. So 15A is done. Next we'll move to 15.1. We have done 15 question 1. Next 15.2, question number 2. Give reasons. The dipole moment of chlorobenzene is lower than that of cyclohexyl chloride. This is very important question. This is chlorobenzene and cyclohexyl chloride is this one. In cyclohexyl chloride, from carbon to chlorine, only sigma moment operates. But in case of chlorobenzene, from carbon to chlorine, sigma moments, it's mu sigma moment operates from carbon to chlorine. At the same time, the flow of pi electrons are happening due to resonance in the opposite direction. So in this direction, a pi moment is operating as well. This is referred as mu pi. So here only one CCl moment is operating, but here two moments, one CCl moment in this direction, another CCl moment in opposite direction. So as a whole, the dipole moment value of this compound mu becomes lesser of this mu. Next we'll move to question 3. SN1 reactions are accompanied by racemization in optically active alkyl halides. Question 3. Here you have to write down as SN1 proceeds through planar carbocation formation. As SN1 reaction proceeds through planar carbocation formation, and a plane has two faces, you just write down. I am not writing down the answer, I am just dictating. You just take your pen and copy and write it down. As the SN1 reaction proceeds via planar carbocation intermediate formation, and that planar carbocation has two faces. So here the nucleophile attacks the carbocations from two sides. So the nucleophile here attacks the carbocation from the two sides, and as a result racemization takes place. So 15.3 is done. Next question 16. The following compounds are given to you: 2-bromopentane, 2-bromo-2-methyl-butane and 1-bromopentane. Well, so what we have to do at first, we have to draw each and every structure. 2-bromopentane. This is question 16. 2-bromopentane. This one. 2-bromo-2-methyl-butane. This one. Next, 1-bromopentane. This one, 1-bromopentane. Well, Now what they are asking for, write the compound which is most reactive towards SN2 reaction. So in SN2 most favorable is 1 degree alkyl halide. This one it is 2 degree. This is 3 degree alkyl halide, but this alkyl halide is 1 degree. So this is most reactive towards SN2. This is the first question's answer. Next, they are asking for write the compound which is optically active. Okay, which is optically active. Sorry, only which is optical. These, look at this carbon. This is chiral carbon, because with this carbon, 4 different groups are attached. Here we are not getting any chiral stuff. Here we are not getting any chiral carbon. So this compound is optically active. Means this compound is optically active. 2-bromo 2-methyl butane. Sorry, 2-bromo propane, 2-bromo pentane. 2-bromo pentane, this one is optically active. Done. And 2-bromo pentane will be the answer, which will be optically active. This is. Next question, what they are asking for, write the compound which is most reactive towards beta elimination. Elimination reaction, order of elimination reaction, you just note it down. 3 degree alkyl halide greater than 2 degree alkyl halide greater than 1 degree alkyl halide. This is the order of rate of elimination reaction. So most readily elimination reaction will be given by 3 degree alkyl halide. So this one is the answer. 3 degree alkyl halide. 2-bromo 2-methyl butane. This is most reactive towards beta elimination. This is the answer of C. It's done. Next, question 17. Identify the chiral molecule in the following pair. This molecule is chiral because this carbon atom, you see, it has this carbon atom. In one hand there is OH group, in another hand there is H, another hand is methyl, and another hand is isopropyl group. As 4 different groups are attached to this carbon atom, so this is obviously chiral molecule. So this is the answer. Next, question B. Write the structure of the product when chlorobenzene is treated with methyl chloride in presence of sodium metal and dry ether. So we are going to solve 17B. 17B. Chlorobenzene plus methyl chloride, sodium, dry ether, Wurtz-Fittig reaction. The main product will be R prime toluene here. 17B is done. Next, 17C. Write the structure of the alkene formed by dehydrohalogenation of 1-bromo 1-ethyl cyclohexane with alcoholic KOH. Okay. C. 1-bromo 1-ethyl cyclohexane when reacts with alcoholic KOH, elimination reaction will happen and it will follow Sadjev rule to form more substituted alkene. So these alkene will be formed as major product. Question C is done. Next, Write equation for preparation of 1 iodobutane from 1 chlorobutane. Okay. No, sorry. Give reasons for the followings. 18a. The presence of NO2 group at ortho or para position increases the reactivity of haloarenes towards nucleophilic substitution reaction. Yes, this is perfect. The reason is that due to strong minus I and minus R effect, you just write it down, due to strong minus I and minus R effect of NO2 group, the carbon halogen bond in the haloarene becomes very weak. The carbon halogen bond in haloarenes becomes very weak, and as a result, these haloarenes become reactive towards nucleophilic substitution reactions, and as a result these haloarenes become reactive towards nucleophilic substitution reactions. Well, next question 18b. Para dichlorobenzene has higher melting point than that of ortho or meta isomer. As para dichlorobenzene, it is most symmetrical in structure rather than meta and its ortho isomer. The structure which is most symmetrical in the solid phase, that structure, the crystal of that particular compound is most tightly packed up due to its symmetry matching factor, which is most symmetrical. And as the crystals of para dichlorobenzene are most tightly packed up due to symmetry matching factor, that's why the melting point of para dichlorobenzene becomes very high with respect to its ortho and meta isomer. It's done. 17b. Next, 17c. Thionyl chloride method is preferred for preparing alkyl chloride from alcohols. So here two reasons are there. One is when we use thionyl chloride, we get two gaseous substance as byproducts along with alkyl chlorides. One is sulfur dioxide gas and another one is HCl gas, which are removed easily from the system. That's why we can get alkyl chloride in pure form more easily. That's the first reason. And the second reason is that as here when we are using SOCl2, as here two gases sulfur dioxide and HCl are formed as byproducts, as a result the randomness of the system increases, the entropy, that means the entropy of the system increases, and henceforth the reaction becomes thermodynamically and entropically favorable when SOCl2 is used here. So this is the second reason. One, you have to tell on the basis of easily separation due to production of gas, and another one you have to mention the increment of entropy of the system due to production of gaseous byproducts, and as a whole the reaction becomes entropically favorable. So question C is done as well. Next we'll move to write equation for preparation of 1 iodobutane from 1 chlorobutane. Well, 1 chlorobutane, this one, to 1 iodobutane, this one. The simple Finkelstein reaction, it will be treated by NaI and acetone via SN2 to give this product. It's done. Next we'll move to next question. Out of 2 bromopentane, 2 bromo, 2 methyl butane and 1 bromopentane, which compound is most reactive towards elimination reaction and why? Yeah, I am not going to discuss it again because it has been done a bit earlier here. So what you have to check, this order you have to keep in your mind: elimination reaction or beta elimination reaction. 3-degree alkyl halide becomes fastest participant in elimination reaction, then 2-degree, then 1-degree. So you check which is 3-degree alkyl halide, and that 3-degree alkyl halide will be the answer. So it's a 2-bromo 2-methyl butane. The structure of 2-bromo 2-methyl butane is like this ones. CH3, CH2, C, CH3, CH3Br. Look at this. This is a 3-degree alkyl halide, and that's why it is the fastest participant in any elimination reaction. Well, it's done. Next, give the IUPAC name of this compound. This compound, we have to write down the IUPAC name of this compound. So, here the double bond, here the main group is the double bond, right? So here the double bond will get the least position. So 1, 2, 3, 4, 5. So what will be the name of that particular compound? 4-bromo 4-methyl pent 2-ene. 4-bromo 4-methyl pent 2-ene. Well, it is done. Okay. Now we will solve some more questions which are not given here. I am just writing the question and solving because you will get more questions to practice, and higher the extent of practice, higher will be the perfection. Needless to mention. As 2014 CBSE paper, we'll try say 2 questions. It is treated with SOCl2. What will be the product? Of course, OH will be substituted by Cl. This one. Next, plus HBr in presence of peroxide. So is HBr in presence of peroxide means is anti-Marconic of addition. So this will be the product, CH2, CH2, CH2Br. It's done. Next, we will try to solve some questions of this chapter from CBSE exam 2015. Is a what happens when type problem. So number 1, they have asked CH3, CH, double bond C, CH3 plus HBr. So obviously here Marconic of addition will happen. This will be the product. Next, question 2, they have asked this one, CH3, CH2, CH2, CH, Br, CH3 plus KOH, ethanol and heat. Ethanolic KOH when reacts with alkyl halide is of course go elimination reaction to give the SADJEF product as major product, means the alkene which has higher number of hyperconjugative hydrogen atom will be the major product. So this will be the major product here. This is done. Question 2. Now question 3. Bromobenzene reacts with methyl chloride in presence of anhydrous AlCl3. They are asking X is formed as major product. Then what is X? Is Friedel-Crafts alkylation is happening. Br any halogen is orthopara directing, but due to steric repulsion here, para product is going to be the major product. So X will be paramethyl bromobenzene. Bromobenzene, a methyl group will be inserted into para position to be less sterically hindered, and that's why this para isomer in this reaction becomes the major product. Well, that's all for today. I think enough questions of CBSE previous years from this particular chapter, haloalkanes and haloarenes, have been discussed, and I'm pretty sure of that if you properly follow this video and the previous video of ISC previous year of this particular chapter, haloalkanes and haloarenes, with basic foundation of this chapter, and if you solve the questions with proper attitude, then I can assure you that no questions are going to seize you from this chapter in your board exam. That may be CBSE, that may be ISC, that may be WBCHSC, whatever the board is. Thank you for watching. Keep sharing our videos, keep sharing good words about Talanta, and if you feel you are being benefited from this video, don't hesitate to share it with your friends. Please like our videos, and the people who are just new on our channel, don't forget to subscribe our channel to get much more updated scientific videos with each passing days. Thank you once more.